Hi there. This is calculus, and we're going to start actually talking about some functions and models. Hope you like this lesson. I've thrown in a few cartoons to keep you occupied. So a couple of things we're going to talk about. Now, make sure that you watch this about 2 times because there are some very good connections with business and volunteer. You're going to use these all semester long. Okay, first of all, before I do anything else, I want to make sure, in case I want to use my pen, that it's there, and looks like we're go with the pen. Alright, first of all, simple interest. Another way of writing this, sometimes you use a small I for this. I equals PRT. And remember, this is simple interest as opposed to compound interest. So this is the simplest, excuse the overuse of the word simple, this is the simplest kind of interest. And sometimes even compound interest looks back at what would be the equivalent if it were simple interest. So what we've got here is, we're talking about money, of course, usually, and I is the interest. That's how much we get because we invest this number of dollars, called the principal. Notice that that's PAL for principal as in interest. Rate is the annual rate of interest as opposed to monthly rate or some other rate. And T is the time, and also make a note here, it's always in years, not months. Not days. Make sure you have it in years. So here is why I'm emphasizing this. If you see a problem and it says something about monthly interest, you have to change it to, or excuse me, if what you're asked for is how much interest do you get for 9 months of investment. The 9 months you have to convert to 3/4 or 0.75 years. Take special note of that. Time has to be in years. Simple interest. Next, compound interest. Now I'm going to alter this just a slight bit because this one refers to an annual compounding rate, but what if it's not annual? What if it's compounded monthly or daily or some other combination, quarterly even? Well, we've got an alternate form here, one that's even more generally useful. Now this A represents how much you have at the end of a certain time. P represents how much you invest. This is just the number 1, nothing else. Plus, so far it looks like it's the same. However, here's where it changes. R over N. R is the annual compounding rate, and N is the number of times the number of times it's compounded in each year. Now, what does that mean? Well, suppose we're talking about compounding monthly. If you're compounding monthly, that means 12 times a year you're going to be doing the compounding. If what you saw was it's compounded daily, that would mean your n would be 365, roughly. I know it's 365.25. And one I left out here, maybe if it's compounded quarterly, that means 4 times a year, and so on. You could even do it per hour, per second, whatever. Those are the most likely ones. Remember, what this means by default is it's compounded yearly, that's annually, and is 1. N equals 1 means that this formula starts looking like the one above. Now, this formula is not finished yet because this had an exponent and this has an exponent. This exponent is n times t. Note that this n down here is the same as this n right here. So if you're setting this up for compound interest, make sure you put the n's twice. T still represents per year, and you put that in the calculator, this part, with the proper numbers at the proper places, and you'll get the amount of interest that you'll have if you invest P dollars at this annual rate and at this amount of compounding per year for T years. That's compound interest, and those are 2 formulas. Remember, the one up here is a special case. This is for the case where it's annual compounding. This equation down here is a more general form. If you remember this one, you can forget about that one. You don't need the first one at all. The one down below will work in all cases. So here's an example. We've got car rental, and it says the fixed cost is $35 per day and a variable cost of 15 cents per mile. So it says first write a cost function. So we want something like this, the cost, and since it has to do with x, it's a cost is a function of x. You can write it like this. That underlines in a way the fact that the cost is a function of x. And what's it equal to? Well, if you run a couple of initial numbers through there for practice, for playing with it, you might say, even if you don't drive the car anywhere, it's going to cost you $35 per day. So one way of writing this would be, if you have 0 miles, you're going to go $35 in one day. But if you do drive, it's going to be 15 cents for every mile. So that 15 cents is going to have to be multiplied by how many miles you drive, plus the $35 that you're paying anyway. So this is how much it would be for one day. If we wanted it for multiple days, then we'd have to adjust it, but this is a simple version. Cost of driving X miles in one day. B, find the cost of driving 500 miles in one day. Well, we can use our function up here. We're talking about 500 miles. So 500 is our X. So we'll just bring this down, but we'll put a 500 where we see the X. So driving 500 miles, we pay the $35 for the day, plus 15 cents times 500. So what do we get? 35 plus, and then you can throw your calculator in there, or you can do it real fast in your head. That'll give us $75. So the cost for driving 500 miles would be $105 even. So here's the answer for the first one, 0.15x. They wrote it in the opposite order, but it's the same. And there's our cost. Oops, I made a mistake, didn't I? Well, let's sneak back here. I was a little bit careless, wasn't I? $110, okay. Moving ahead, there's our $100. And one last note, if you don't drive it, you still owe $35 for the day. Next, we've got another example, and we're talking about revenue. So what is revenue? Revenue is how much is coming into your cash register, into your business. So if you sell 17 TV sets at $200 each, 17 times the cost for each TV set would give you the revenue. So it says, what's the revenue generated by selling X units of a product? The revenue for 20 is $380, and the revenue for 15 is $285. So how do we do that? Well, we've got two things going. We've got the revenue and the number of units, and we've also got I guess that's it. Revenue in the units. So what do we have? Well, we have ordered pairs. From this first up here, if we put the number of units first, and we put the revenue as the second coordinate, from this first one up here, we'll have 20, 380. 20 units, we get $380. We also have a second set of ordered pairs. The units come first, so the 15 is here, and the 285 goes there. Now, one tip for you, units and revenue. We decided we put the units first, the revenue second. So what you might want to do, before you write these down, you might want to write something like this. Units. This is how your ordered pairs go. That way you don't accidentally mix these two up if you've actually got it written down. And the units, maybe you're going to call X, and the revenue, maybe you want to call it Y, or whatever you want to call it R. That's up to you. Now, we've got two ordered pairs. How can we get an equation out of that? Well, we've got a couple of things that are going to help us. We want a revenue function. So in this case, what we want is something like this with an X in it that gives us the revenue, or R if we want to use R, and somewhere in here we'll have an X. That's our revenue function. Now, how do we get that? We've got two ordered pairs, and we've got some basic equations we can use. First of all, we could use those to create the slope. This is a good reminder of how we calculate the slope. Take the second x coordinate minus the second y coordinate minus the first y coordinate divided by the second x coordinate minus the first x coordinate. That will give us the slope. Now, slope isn't just a number. In this case, since there's revenue on the top and units on the bottom, the slope in this case will represent how much revenue you get per unit. So we can calculate the slope for this as 380 minus 285. Subtract those y coordinates, both here, and then subtract the x coordinates on the bottom. But one thing you do have to be careful about here is you subtract those there. Subtract those in the same order. You have 380 minus 285. So in these ordered pairs, we're subtracting downward. 380 minus 285. So when we subtract the x's, we'll have to subtract those. 20 minus 15. 20 minus 15. So what is our slope? Our slope, 380 minus 285 will be 95, and 20 minus 15 is a 5, so our slope is 19, and translated, remember, it's revenue per units, so this would be dollars per unit. We don't have an equation yet, though. This gave us the slope. That basic formula gives us the slope. Subtract the y's on the top, subtract the x's on the bottom, make sure you're subtracting in the same order. Next, what we need is another formula that you really need to write down. Maybe you need to write down the one for the slope, maybe you don't. That's up to you. This next one is called the slope-intercept form. It's y minus y sub 1 equals m, same slope we talked about a minute ago, times x minus x sub 1. Here's one that it's well worth memorizing. Now, frankly, I do not care for memorizing when I don't have to. This is one that if I go all the way back to Algebra 1, I decide, well, since I know some other formulas, I can always put this together. However, knowing this formula can make things much simpler for you. So take my advice, memorize that one because it's very useful. Now, all we need to do, once we have these two ordered pairs, number one, find the slope. Number two, this will give us the equation. In this equation, going through it, y is the generic y that we're going to have for our equation. It represents all the y coordinates. The y sub 1 represents a particular y coordinate. Now, you can choose the 380 or the 285, it doesn't make any difference. But once you choose which y value you're going to use here, then you have to use the corresponding x value in the second part. So let's suppose we decide we're going to use the first order pair and use that for our x sub 1 and y sub 1. So that gives us, rewrite this up here, y minus y sub 1 equals slope times x minus x sub 1, and we'll fill in the blanks with the ordered pair 20, 380. What does that give us? Y, the generic y, minus y sub 1 will be 380 equals the slope we found down here. The slope is 19 for this function, and x is the generic x minus x sub 1, we're using 20 up here. In rough draft, this is our equation. However, it is a rough draft. That's not the way you express it. We want it to look something like this. So let's clean this up. Y minus 380 equals 19x minus 380. I'll add 380 to both sides. And that gives us y equals 19x. And if we want to, we can say x is the number of units, and maybe we want to call it r, usually capital R. So when we write our final equation, we might want to write it like this, r. And it's going to be a function of x, so we'll say r of x equals 19x, and there is our revenue function. We've got it. Summarizing, the revenue function is linear, we're told that, and we've got two ordered pairs or 2 points on a line. There's our formula for the slope, our point slope form. Remember my tip, memorize that one. It's very helpful. At the bottom here, we're calculating the slope. That was our 19 that we got on the last slide. Put it into this point slope form, clean it up, and switch the y to an r because it is the revenue function. And we've got our equation and the answer to our question. All right, let's take a look at another one. Remember, we're talking a lot about business. And here's the Greenbelt Company. No, not the Greenbelt outside Washington, D.C. This is the Greenbelt Company because we're making belts. Not necessarily green, but I guess they're environmentally conscious. They found out that the cost is $2 each, $2 for each belt, plus $300 per day in fixed costs. So, before we go any further, what do we mean by the fixed costs? Well, if we're going to make those belts and sell them, we have to pay the heating bill, we have to pay the lighting bill, we have to pay our employees, we have to pay insurance, all kinds of things. The $300 covers all that. Now it says, what's the break-even point if we sell the belts for $3 each? Well, the break-even point means this. We've got money coming in, and the money coming in is called the revenue. There we go, revenue. That's the money coming in. We've also got costs. Call that C. That's typical. Now, the break-even point means where do we break even? When does the revenue equal the money we're writing checks for? Another way of writing that same thing is, if I take the revenue, the money coming in, subtract what I have to pay, what we end up with is the profit. This break-even point is when the profit equals 0. If you take those two together, you can get R equals C. So it represents the same thing. However, this is another good one that you could figure out logically, but you need to have that in the back of your mind. Profit equals revenue minus cost. The break-even point is when the profit is exactly 0. If you don't make enough money or enough revenue, then your profit is going to be a negative amount and you're paying out more than you take in. If you make enough money to cover the costs and then some, you actually have a profit, maybe $10, $100, whatever. So the question is, where's the break-even point? So I'm going to use this formula right here because it's a more general one. The break-even point is where you have a profit of 0. So I'm going to take this equation and write it down here. 0 is the break-even point, and that's the revenue minus the cost. Same thing as we've got here. The question is, though, what's the revenue function? What's the cost function? Well, not too bad. The revenue. So if we're selling the belts for $3 each, and we sell X of them, it's not too hard. Play around with it a little bit. So for example, let X equals the number of belts sold. There we go. Now, if you play with this, if you sell one belt, you make $3. It's $3 of revenue. If you sell two, $6. If you sell 17, 17 times 3, $51. How does that work? Well, let's look at this 17. 3 times 17 gives us $51. What part did I make up? I made up 17. It's really X, because it could be different on different days. So our revenue function is $3 times how many of those belts we sell. There's our revenue function. That's not too hard. Now we need the cost function. Now the way I do this is I look at the fixed costs, because even if you don't sell any belts, there's a cost. Well, if we look above here, it says we sell the belts for $2 each, or excuse me, it costs $2 each to make. but we also have to spend the $300 per day regardless of how many we sell or make. So first of all, we're going to have to pay that $300. What else do we have to pay? We have to pay 2 times or $2 for each of those belts. 2x. If we make 5 belts, it's going to cost us $10. 310 total. So we've got a revenue function and we've got a cost function. So what we've got is at the break-even point, revenue is 3x minus the cost function, which is 300 plus 2x. That's going to help us find the break-even point. So what do we have? We've got 0 equals 3x minus 300 minus 2x. 0 equals, the x's subtract, we get an x, minus 300, which I've got minus there. So add the 300 to both sides. X equals 300. I know the temptation is to say the answer is x equals 300. Well, that's not answering the question. The question is, what is the break-even point? In other words, how many belts do we make and sell so we break even? Make and sell 300 belts to break even. There is our answer. Take note, we had word question, 4 lines. Our answer should be a word answer, and it should be a complete sentence. All right. So the break-even point, revenue and costs are equal, or profit equals revenue minus cost equals 0. That's our break-even. Those are our 2 functions, the revenue function and the cost function. For revenue equals cost, set those 2 equal, set for x, and there is our answer. If you want to make a profit, you have to sell more than that 300 break-even belts each day. Let's move on to another one. This company decides that the cost of producing X items, belts, or whatever you want to choose. This is where you get to be a little bit creative. You can choose what your company is selling. Well, it says that if you produce X items, your cost is 500 plus 140X. And the price you're going to charge for each one of those is 200 minus x. So first of all, what is the cost function? So let's take a look here. We want the cost function, and it says the cost of producing X items is, well, there it is, 500 excuse me, plus 140x. Check. Revenue function. Okay. This sounds a little tricky. Well, not too bad, actually. Here's where you get to learn one more thing about revenue. Now, revenue, remember, if you have an item and you're charging $20 for that item, you want to find out what the revenue is for selling a certain number, just multiply those two together. In general, That means the revenue as a function of x is the number of items times P, the price. Very simple. However, P equals 200 minus X. So for this particular case, our revenue function will be X times P, which is 200 minus X. Rewritten, our revenue function is 200x minus x squared. Next, we want the profit function. Well, remember, profit equals revenue minus cost. Remember I told you that was more important than remembering the break-even one? So all we have to do is put the numbers in. Both cost and revenue are functions of x, so profit will also be a function of x. And the profit will be revenue, that's the 200x minus x squared, that's revenue, minus the cost, and the cost is 500 plus 140x. Here's our profit function. Let's see what that really is. Profit function equals, so simplifying, we've got 200x minus x squared minus 500 minus 140x. So if we put these in our typical order of minus x squared plus 60x minus 500, and that is our profit function. Part D says, where's the break-even point? The break-even point is where the revenue equals the cost, or the break-even point is where the profit is 0. So if I take this profit function and set it equal to 0, I have minus x squared plus 60x minus 500 equals 0. To make this a little easier to work with, I'm going to multiply through the entire equation by -1. That'll give me x squared minus 60x plus 500 equals 0. Now you could use the quadratic formula, or you could factor it. Fortunately, it's not too hard to factor. X minus 10 and x minus 50 will be factors of x squared minus 60x plus 500. Set each of those factors equal to 0. X equals 10 from this one. X equals 50 from this one. So, our answer. Notice we've got two break-even points. They're both positive numbers, so they're both reasonable values for the number of units. Has two break-even points at 10 units and 50 units. If we make 10 units and sell them, we break even. If we make 50 units and sell them, we break even. There's the work we just did, in case you want to look back at it. Break-even point, set the revenue equal to the cost. or set the profit equal to 0. We get the 10 and the 50, there are 2 break-even points, and there's a graph showing you how it works. Notice at the bottom, at the very beginning, when you're only making and selling, say, 5 or 6 units, you're actually losing money. When you get to 10 units, you're breaking even. You don't make any money, but you don't lose any money either. Above 10, you're making a profit until you get to making and selling 50 units. And then you break even again. If you make more than that, you're starting to lose it again. So if this is your business, you're going to keep your production between 10 and 50 so that you make money. Next, we've got a supply function for a particular product. We've got a demand function. Now notice the demand function, even though it's called the demand function, it's in terms of P, the price. You want the equilibrium point, also break-even point. So how does this work? We're going to solve for x by setting the demand and supply functions equal, revenue and cost. So here we've got both those functions set equal to each other. We expand the right-hand side. Fortunately, in this one, the x squares cancel each other out, subtracting x squared from both sides, they're gone. Subtract 3 from both sides, you get the 22, and adding 10x to both sides gives you 11x, so we have 11x equals 22, or x equals 2. The break-even point is where x equals 2,000 units, because if we sneak back here, P represents thousands of dollars. X represents thousands of units. So when you give your answer, you have to make sure you put the proper units on them. X is in thousands, so this x equals 2, x represents 2,000 units. And the 9, which is the price, is $9,000. So make sure you go back and using your found values, you put things in the proper units. Maybe it's in thousands, it could be in millions in some cases. Next, we're going to sneak in the physics. This basic law of physics, this might sound familiar to you if you've taken that. An object dropped in a near vacuum, that means there's no air resistance. We're making things simple. The distance it falls varies directly with the square of the elapsed time. One way of writing this is distance is proportional, directly proportional to square the time, and the way you put those together is, since it's proportional, that means there's some constant that allows you to relate the distance and the elapsed time. So this is your equation, except that you don't know what K is yet. Now the good part is that you want that equation, and you're also given some more information. You're given that 64 feet is how far it falls in 2 seconds. Those two values go together. So you can take this d equals kt squared and put those values in there. So 64 feet is how far it's going to fall if it falls for 2 seconds. Putting those two connected values or related values into that generic equation allows you to find out what k is. So 64 equals 2 squared is 4, so it's 4k. So k equals 16. So our equation is d equals 16t squared. Once we've got our equation, we're in business for answering the question. It says, how far does it fall in 3 seconds? So all we need to do, since this distance is a function of time, or elapsed time, 16t squared, all I have to do is put the 3 in where the t is. So the distance that it falls in 3 seconds equals 16 times 3 squared, or the distance it falls in 3 seconds is 16 times 9, which is 144 feet. Notice we've got seconds up here for the time and feet for the distance. (144 feet in 3 seconds is how far it'll fall. And, of course, in business, we might have to do something with the stock market. So let's take a look at that. Scott wants to buy some shares in the stock market. He's going to buy X shares. He hasn't decided, in other words. He's going to buy X shares at the $4 per share stock and the rest at the $6 per square stock. So first it says, write a function for the total cost of the shares. So X equals what? It says X shares of the $4 per share stock. Number of shares bought at $4 per share. Notice that he also buys some at $6 per share. So what about this? The number of shares bought at $6 per share. We need something for this. Now what we could do, one possibility, would be to put Y there. And if you have X shares here, Y shares there, then you could write, since he's going to get 500 shares, you could write the equation X plus Y equals 500. The catch, though, is you'd rather have just one variable. Well, what you can do, if you do choose at first, put a y there, you could solve this for y. Subtract x from both sides, and the y value is actually 500 minus x. Well, that makes sense. He's buying 500 shares, x of them are at this price. Well, if you subtract the number he did get at $4 per share from the 500, that's how many he's buying at the $6 per share. So you could just straight away Write 500 minus x as the number of shares at $6 per share. Now you're ready to write a function for the cost of the shares. And all we need to use is x, so cost is a function of x. Now, he's buying shares from one place, shares from another place. For the $4 stock, he's buying x of those, so it's 4 times how many? $4, how many shares? So if this is 85, 4 times 85 would be how much he paid for the $4 shares. Plus, he gets some at $6. How much? $6 per share. How many shares? Well, up here we've got 500 minus x. How many shares are left after he decides he's going to buy 500 and he already spends to get x shares of the first one? There's our cost function. Second part. What will be the cost if he buys 200 shares at $4? So since x represents how many shares at $4, we can just put a 200 in here and put 200 in for each x. So I have 4 times 200 plus 6 times 500 minus 200. What do we have for our cost? For buying 200 shares of the $4 per share stock, with 800 here, and we've got 6 times 300, or 800 plus 1800. And that's how much he's going to pay if he buys $200 of the $4 per share stock. There's another summary. And example number 8. Now this is the tricky one, but the one that definitely is used every day. We have an overseas call. You pay $9 for the first 3 minutes or less. Pay $9 for the first 3 minutes, no matter how much do you use up to the 3-minute limit. Plus, if you go over the 3 minutes, it's 95 cents for every minute over that. So writing a function of the call is not quite as straightforward as the previous ones. And notice that it says, assume the fraction of a minute over 3 minutes is charged by a corresponding fraction. So what does that mean? Let's suppose your call is 20 minutes. This gives you an idea of how to put the function together. Now, how would you get the cost? Okay, the first 3 minutes are $9. That's for the first 3 minutes. Now, you stay on the line for 20 minutes, which means you've gone 17 minutes over. Next 17 minutes. Each minute over that costs 95 cents. So the next 17 minutes are going to cost you 95 cents per minute times the 17 minutes. Now, if this isn't an even number of minutes, then this will be a fraction. So, for example, if you stayed on the line for, let's say, 25.3 minutes. Oops. Anything up to 3 minutes, you're still spending $9. Now you're going over by 22.3 minutes. How much is that going to be? Well, you don't take the 23 minutes and the 0.3 minutes and round them in any way. What this means is this fraction will become a fraction in number of the dollars. So you just take the 0.95, which is how much per minute, just multiply it straight by the 27.3, and these together will give you how much your charge is for this 27.3 minutes. A fraction here will give you a fraction of the 0.95 cents per minute. So what does this look like? We've got two different operations going on. So let's take a look at it. This is called a piecewise function. What that means is you first have to look out here and see how many minutes you're actually spending online. If it's anything up to 3, then the calculation is very simple. If it's over 3, then you calculate it using this formula instead. Here's the $9 you're going to spend regardless of how long it is. And then after that's 95 cents per minute. Well, remember, you already paid for the first 30 minutes, so you take your time online minus the 3 you've already paid for. That's how many minutes over the 3 minutes you went. And for each minute over, you pay 95 cents. So 0.95 times how much you went over the 3 minutes. And there's your second calculation. That's a piecewise function. And last of all, we've got a perimeter problem, and we've got something for which we can actually draw a picture. When you can draw a picture, that is definitely the way to go. So we've got a rectangular lot. If you look down here, maybe that's where we keep our dog. Or maybe that's where we keep our cat. I don't know. What we have is something we can draw a picture for. If we take this lot, convert it into a picture on which we can draw each of these sides of the rectangular lot are x's. Now it says the length of the fencing is 48 feet. That means these two sides plus this side is 48. So we've got this, and this, and this. We put all three of those together. We've got 48 feet. So how can we express this side? Well, if this were 3, for example, and this were 3, then there'd be 6 feet of siding used up here, and we'd still have 42 feet left. Another way of putting that is If we want the length of the third side, we have 48 feet of fencing for all of it. 2x is used up for the two sides of the rectangle. So we've got three sides. The three sides are x, and 48 minus 2x. What we want is something that represents the rectangle. We move to the next slide to get a little bit more room, so you might want to pause and write down anything you need to keep. So, we've got a rectangle. Here's our rectangle. Remember we said the two smaller sides are x, and this side was 48 minus 2x. The area for a rectangle is length times width. So the area for our rectangle will be x, which is one side, 48 minus 2x for the other side, and since those are all x's, the area is going to be a function of x. To finish it up, we'll expand this. 48x minus 2x squared, and that is the function we need. And we can graph it too. You might want to grab your TI 84 CE or something similar if you got it, or your TI Inspire. It's one of my favorites. So there's your area at the bottom. Put this in y equals with the y equals key. Hit the graph, and what do you see? You should see something like this. Notice that it has a maximum. We're going to talk a lot about maximum in the future. The maximum hits right around 12 feet. In fact, exactly 12 feet. It's hard to tell from the graph, but we'll find ways of finding that exactly in the future. It's real easy. I'll give you a tip on that. It does use some calculus, but it's not a big deal. It's real easy. And that gives us our answer. If you make the width 12 feet, you're going to get the largest area you could possibly find at 288 square feet. Any other dimensions, and you'll have a smaller backyard. All right. This has taken a while. I hope you paused it when you needed to. Send me any questions you got. Bring questions you can't put in email, or maybe either way. Bring those to class next time, and we'll talk about them. Okay, until then, I'll see you. Keep smiling. Hope to see you soon. Bye-bye.